Okay. Do you remember doing long division and synthetic division last year? Okay. Was there anything that wasn't clear in either the book or the video, whichever one you chose? Was there anything that wasn't clear that you wanted to get clarification on? Okay. We are going to do synthetic and long division today. Okay, we're just going to do it in our examples. Okay, so if you're still a little shaky and you don't want to ask a question right now, we're at least going to do some examples to where we'll get back into the groove of it. Okay, synthetic division is one of my favorite things to do. Okay, so I'm really excited about today and Friday and Monday because we get to do it a lot. Okay, so let's kind of remember what we do for division. We have some vocabulary words. We have something divided by something. What? Numerator and denominator. But in a division problem, they even have cooler names. Which one's the divisor? Okay. Joe, what's the numerator? Yes. And when we take that, it equals the quotient. Okay. Now, if we have anything left over, then we have to tack on the remainder over whatever the divisor was. If we take 10 and divide it by 3, we get 3 with 1 left over, so we say 3 and 1/3. Okay. Now, what I'm going to do, I'm going to give these function names, okay? We are in our polynomial chapter, so we're going to take a polynomial dividend divided by a polynomial divisor. Okay, so I'm going to call our dividend f of x. We're going to divide it by our divisor, d of x. Our outcome is going to be our quotient, q of x, plus our remainder, r of x, over our divisor. Okay. When we take polynomial divided by polynomial, our quotient is a polynomial. We can probably figure out what degree it's going to be also. Our remainder will be a polynomial, and we throw that over our polynomial divisor. Okay? Now, just look at that equation that I have up there. If I wanted no fractions, what could I do? I want no fractions. Okay, don't write this down, just watch me. I could multiply both sides by d, which means d of x and d of x cancel. Q of x gets multiplied to d of x. And then here, d of x and d of x cancel. Basically, I've taken this blue equation and I just rearranged it. I took our divisor and multiplied so that we have no fractions. Okay? This is what we call, do you have the blue written down so you know where it's coming from? This is what we call the division algorithm. And what I want you to do, I want you to write the division algorithm. Don't write any of this garbage down. We talked about it. They're polynomials. We know they're polynomials. I just want you to write that the division algorithm is this that we just rearranged. Okay? It's basically taking your dividend and rewriting it in terms of the divisor, quotient, and remainder. Okay? It is going to change nothing that we do in terms of our division. It's just another way of rearranging our items. I don't know about you, but I'm excited for some division. Okay, you don't have to be excited. I get that we're not all as excited as I am about math in general, let alone division, but I'm excited. So, I would like you to write down this problem. Don't do anything with it yet. Just write it down. Reagan, we want to take 2x cubed, blah, 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 and divide it by x squared plus 1. If we were to choose a method, long division or synthetic division, which one would be best?
Or not synthetic. I would do long division.
You would do long division. Okay. Reagan is saying long division. Nathan, why is long division the best?
Well, one, it says long division on top.
Ah, dang, it does. What's another reason why long division is going to be best?
Because there's a bunch of x's we can take out if we do long division.
What do you mean by that?
There's a 2x cubed and then an ax squared and a 3x. So if we broke apart the x squared plus 1, we could factor out a lot of the same stuff again.
Okay. Okay. Reagan, you have more to add to that?
You're dividing by x squared and you have to have x plus something.
Okay. Synthetic division, you have to have a linear divisor. Okay? And since this is not a linear divisor, we really have no. Okay? But you're kind of seeing how it's going to unfold. Like you're excited about what it's going to happen. Okay? All right. So we have x squared. Oh, I didn't put this in right. Still didn't. I missed this one. And I'm going to write this as x squared plus 0x plus 1. You don't have to, but anytime there is a missing term, you have to write a 0 under the division bar. When it's in your divisor, I can be a little bit more flexible, but maybe just to get in that habit, let's go ahead and do it now, okay? But if it's in our dividend, we have to put a placeholder there. Okay, so now let's do this. X squared times what is 2x cubed? 2x. So I'm going to put it in our x column. And we are going to take our divisor and multiply it by that 2x. So we have 2x cubed plus 0x squared plus 2x. Okay? And remember, we are subtracting. My suggestion is to just change all of the signs to carry the subtraction through. This should always go away. Okay? And we are left with negative 8x squared plus x, and then we take down minus 9. Once you take down that last term, you know you're going to be in your last division process. Okay, so this is the last time we're going to have to do it. All right, x squared times what is negative 8x squared? Negative 8, that was a nice one, right? So we'll put it in that constant column. Now we take our divisor and multiply it by that one term that we wrote. So we have x squared times negative 8, 0 times, it doesn't matter, and 1 times negative 8. Okay. And we're subtracting, so my suggestion is that you just change all of the signs. These cancel, and we are left with x plus 1 minus 1. X minus 1. Negative 9 plus 8. Okay, so what we did, let's see if I can get it all. Yes.
The 0x.
Mhm.
So when you put that, you got the 8 because it's what's
Mhm.
multiplied, right?
Yep.
What would to become? Is it the 0x to become the a squared?
We just take everything in our divisor and multiply it by negative 8 for here. So like 0x times negative 8 is 0x.
Because it. Because I thought it was whatever you would have to times that like piece to become a different.
It's
word.
just this first term.
Oh, okay.
Yeah. This first term times what gives us this, which is why we chose
Oh,
negative
okay.
8, and then we take the rest of it into account.
All right. Yeah.
All right, so sorry, I have to kind of scooch down here. But we determined that 2x cubed minus 8x squared plus 3x minus 9 divided by x squared plus 1, that was our problem. It equals, our quotient was 2x minus 8. And then we add our remainder over the divisor. So if I ask you purely for a long division, that's our answer. What we wrote down on the previous page, the division algorithm, is just saying we can rearrange this. We can take both sides and multiply by our divisor. If we were to do that, it would cancel out in the denominator here. It would multiply to the quotient, but then cancel out in the denominator here. If we multiply both sides by the divisor, it cancels out the fraction here. We multiply it to 2x minus 8. It cancels out the denominator in this fraction. All right. So let's get into some cool stuff. What else can we use synthetic and long division for other than to divide polynomials? Okay? It can do more than just give you a quotient. Okay? The first cool thing it can do is it can tell you what a function value is. If we divide a polynomial by x minus k, then whatever the remainder is the function value at k. Write it down, and when we do an example, I can explain to you what that means. So when we divide by x minus k, the remainder is the function value at k. So in order for us to wrap our brains around that, let's go ahead and write down this example, okay, so that I can show you what I mean. Is our divisor linear? Heck yes. Okay? I'm excited when our divisor is linear because that means we can use synthetic division. Okay? So we have 2, -8, -3, -9. I do not have a missing term, so I don't need to put a 0 placeholder. And if we're dividing by x plus 1, then the number out here needs to be what, Madeline? -1, okay? This is x minus k. Okay, so we need to think of it as x equals -1. We kind of solve for it, okay? All right, let's do our synthetic division. Some of you probably have already started without me. We drop the 2. 2 times -1 is -2. Add to get -10. We multiply -10 and -1 to get 10. We add to get 7. 7 times -1 is -7. And we add this column to get 16. Our remainder is -16. Yes, we've taken a third-degree polynomial and we've divided it by a first-degree polynomial. So this is going to be a second-degree polynomial. 2x squared minus 10x plus 7 minus 16 over x plus 1. We know how to do that. However, what this is saying up here is that if we call this f of x, then what we just did is we found that f of -1 equals -16. F of -1 is -16. So basically, instead of having to plug -1 in without a calculator, we could do this synthetic division and know what our function value is. Do I expect you to do that every time? No, but it's a neat thing that we can do. We have an option. If you don't have your calculator and you don't want to plug and chug, synthetic division goes pretty smooth. So what I want you to do, I want you to find me f of 5 for this function. Set it up, find it, and check your answer with a neighbor. Check your answer with a neighbor when you get it. Oh, sorry. Maybe talk about what you think it means. Caden, what'd you get?
For the entire equation?
For the remainder.
5.
You got a remainder of 5. Okay, so you took 2 times 5 to be 10. Add these to get,
Take the 5.
okay, -5 times 5.
-25.
Add to get,
3. Right? Oh, 2. That's where I went.
and then 2 times 5 is,
10.
I put a smiling faces in my zeros. We got a remainder of 0. What does that mean? There's no remainder. What else do we know? We know f of 5 equals 0. That's pretty cool. We know a 0. What else do we know? 5 is 0. What else do we know? X equals 5 is a 0. We know that. Did we do division? What did we divide by? We didn't divide by 5, we divided by x minus 5. And x minus 5 divided evenly into our function, right? So we know that x minus 5 is a factor. Okay? When we get a remainder of 0, we know a 0. We know a factor. We can use both of those to help us. Okay? This is generalizing what we just said. If x minus k divides evenly into our function, then f of k equals 0. Okay? If x minus k is a factor, then f of k is a 0. Basically, if we have a factor, we know a 0. If we know a 0, we know a factor. Okay? It goes both ways. And we can use this to help us determine factors. If they divide evenly into our function, we know that they're a factor. And then that helps us know our zeros, which could help us eventually graph our polynomials. Okay, it's all going to come full circle. We can determine our zeros. We know what the graph is going to look like. Okay. So what we've been doing the past 2 days with our graphs, we're going to keep doing that as we add on each day. Okay? Okay? You are going to see this. Verify blah, blah, blah is a factor. Go ahead and write it down so you see how it's worded when you look back in your notes. And you are available that day, right? Yeah. We want to verify that x plus 3 is a factor. Okay. Well, if I use synthetic division and it is a factor, what should happen?
The remainder should be 0.
That remainder better be 0, and we'll be happy about it, right? We'll be very happy about it. Okay? So let's go ahead and perform synthetic division. So we have 3, 2, negative 19, 6, and out here we're going to put a negative 3. If x plus 3 is a potential factor, then we want to put a negative 3 outside of our division bar. So we have 3. 3 times negative 3 is 9. Add to get negative 7. Negative 7 times negative 3 is 10. We add to get negative... Whoa, what am I doing? Yeah. Easy to make mistakes, right? 21, is that better? So we had to get 2. Okay. Negative 6. So you could tell me, yes, this is a factor because we divided by x plus 3 and our remainder is 0. That would be your justification. Okay. Now, let's keep talking about this, okay? Because we're eventually going to have to keep going, all right? What we did is we took x plus 3 and we divided it out, right? So we know that x plus 3 times this leftover 3x squared minus 7x plus 2 would multiply together to be our original function? Well, if I'm eventually needing to find the rest of my zeros, could we do that? Yeah, we could. Now let's talk really quick. How did I know that that was 3x squared? Blah, 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 blah. We started with a third degree function. We divided it by a first degree function. So when we take a third degree divided by a first degree, we're left with a second degree. Okay? So now, if I needed to find all of the factors, I could take 3x squared minus 7x plus 2, and I could factor it to 3x minus 1 and x minus 2. Okay? When you're factoring, you need to make sure that these two multiply to be that positive 2, but then your O and I of the FOIL, they combine to be your middle. So negative x and negative 6x would add to be our negative 7x. Okay? So here are our factors, which we could then figure out what our zeros are. If I wanted to, I could say, hey, I have zeros of negative 3, positive 1/3, and positive 2. And we can draw a graph if we want. Okay? Eventually, all of this is going to come together. Do you remember when you did synthetic division over and over and over by kind of like, not guessing random numbers, but you had to like try a number and maybe erase and then try a number? Okay, we're getting there. Okay, that we will get there very soon. I have one more example for you. Okay. Go ahead and write it down, and we'll spend our last few minutes of class working it out. Have about a 20-second conversation. I don't think it's going to take awfully long. But have a 20-second conversation at your pod. What can we do with x minus 5 and x plus 4, and what do we know about them?
So
Okay. All right, Kelly, what do we know?
That you can plug in the x minus 5 and x plus 4 and find your zeros.
Okay, so we know that x minus 5 and x plus 4 will give us two of the zeros. Okay, we know zeros are 5 and negative 4, right? Okay, what else do we know about those factors? Brecken, what's another thing that you guys maybe talked about? And what was that conversation?
So you would plug in like 5 and this is what it is for that. And then once you get the answer, you put the answer to another.
Okay, so Brecken's saying we can do synthetic division twice, once with 5 and then again with negative 4. And so between Kelly saying, hey, we have two zeros already, 5 and negative 4, then we're going to do synthetic division twice. We can probably get all 4 of our zeros. Okay, so here we go. Our original equation is x to the 4th minus 4x cubed minus 15x squared plus 58x minus 40. Don't panic. I know that those seem big. It'll be fine. So let's start with x minus 5. So we're going to go throw a 5 out front.
-10.
Hey, we knew that that would happen. If x minus 5 was a factor, we better get a remainder of 0 when we take that through. Okay, now what Brecken mentioned, we don't have to start over. We can go from here. Okay, we can do synthetic division again, but this time we're going to do the synthetic division with what we have left over. We have a third degree polynomial now that we can use synthetic division with that x plus 4 factor, and it should still divide evenly into what we have left over. Are you getting 0? Okay, and we knew that that would happen. Okay, but now what's nice, since we did synthetic division 2 times with our 4th degree polynomial, we now have a quadratic. And once you have a quadratic, you can solve it. You can solve it by factoring. You can solve it by the quadratic formula if you can't figure out how to factor. It might not factor and you have to use the quadratic formula, but you can solve a quadratic no matter what. So we know that x minus 5 is a factor, x plus 4 is a factor, and left over from our synthetic division is x squared minus 3x plus 2. We can factor that, right? X minus 1 and x minus 2. Here is our 4th degree polynomial, factored all the way out, so that if we want our zeros, easy peasy, right? X minus 5, set it equal to 0. X plus 4, set it equal to 0. X minus 1, set it equal to 0. X minus 2, set it equal to 0. And if we really wanted to, we can plot those on our x-axis and make our graph. Okay. All right, so I gave you an extra day on those quiz reworks. Okay, so have those ready for me tomorrow if you didn't turn it in today. You have 8 problems for your homework tonight. Nothing extra. Now, on your gold sheet, it does say that there's an extra practice 2.1 to 2.3 in the extra practice column. If you are having any difficulties from anything from today through last Thursday, I'm going to put a worksheet and answer key online if you just need any extra practice. That could be today, that could be a week from today, it could be 2 weeks from today. But if you ever need extra practice, I'm just going to put it on my website. But for sure, you have 8 problems that I need you to do. Okay? Cool.